Before we officially start production, we need to understand the proportions of the female body first, including some of the rhythm and cadence of the body. This will better help us to create this basic body model. This is a female anatomy model that comes with ZBrush. You can access it through the file in the Lightbox 2 folder. Originally, this was an 8-head tall female model. But modern aesthetics, or the ideal female body ratio, should be around 8.5. So I made some slight adjustments to this model. I adjusted it to an 8.5 head tall ratio. From this model's perspective, one big difference from the past is that people now prefer to see longer legs, longer lower limbs. In other words, from the calf muscles upwards, at this point, what people usually refer to as the mermaid line, the starting point of the vest line, and all the way to the soles of the feet. This height is approximately 5 head lengths. Then the position of the waistline is higher now. In the past, the position of the waistline was approximately at 5 head lengths, but now it should be around 5.5 head lengths. Now let's look at the knees. The kneecap is called the patella. It is located in the middle of the entire leg. Right in the middle of the leg, that is, at 2.5 head lengths high. Moving up to the torso, we find the position of the nipples. The position of the nipples is often along a line from the shoulder peak to the navel. So, in the past, the horizontal position of the nipples was often at the level of the second head length from the top to bottom. But now, because people prefer to see a more elongated neck in female characters, a more graceful curve, the position of the nipples may be slightly lower. It's lowered to about 2.25 head lengths, or about 2.5. Observing the entire body, from top to bottom, the midpoint is exactly the position of the pubic symphysis. The pubic symphysis is part of the pelvis. Where the left and right pubic bones meet is the pubic symphysis. Next is the length of the arms. Many anatomy books mention that the upper arm is 1.5 head lengths long, and the lower arm is 1.25 head lengths long. But I think it's more convenient to judge based on the position of the bones. It's more convenient that way. When a person's hands naturally hang down, the end of the ulna bone is basically at the lowest point of the 10th rib. The horizontal position at the lowest point of the 10th rib. Then, when the hand is hanging vertically, its end point is at 1/3 the length of the ulna bone. 1/3 of the length of the ulna bone from top to bottom. So, using these two reference points, we can basically determine the length of the hand. These are the main points of good body proportions. That's basically it. Next, we also need to understand some of the rhythm and cadence of the female body. Let's first do a dynamesh on this side, because its topology is clipped. So I want to use that point color later to explain to everyone. So after dynameshing, I'll fill it with a white vertex color. The model is a bit broken after dynameshing, but it's okay, it won't affect the explanation. First, let's analyze this torso part. Throughout history, when describing the female torso, the word gourd is often used to describe it as a gourd. In other words, the upper and lower body of a woman. Thoracic cavity, plus the transition from the upper to lower body. The pelvic area. It's almost an overlap of two ellipses. So the intersecting point of this overlap happens to be at the waistline. So through this shape, we can identify several curves. First, the first one. From the side of the chest. Down from the side of the chest. To behind the waistline, turning towards the front of the chest. All the way to the lower abdomen. Down along the external oblique muscles. All the way to the lower abdomen. We see a curve like this. This curve represents the form, from the side turning to the front. This kind of twisting relationship. The second curve starts from the waistline, passes through the serratus anterior, moves towards the front, almost down along the rectus femoris, then reaches the adductor muscles, then back again, until it reaches the knee. This curve also forms an S shape. We find the connection between the trunk and the lower limbs is also a twisting relationship from back to front. These are the two curves. The spatial position of these two curves almost determines the entire front of the trunk, the overall form of this body. Next, let's look at the lower leg. From the lateral malleolus. This point is called the lateral malleolus, starting from this lateral malleolus. Then downwards, passing through this.
Anterior tibial muscle.
Then moving towards the inside, reaching the tibial shaft. Finally, at the ankle, medial malleolus, it ends at this point. It's actually also an S shape, a curve, from the side to the front. Then turning towards the inside in this kind of curve. This curve determines the form and direction of the front of the lower leg. After analyzing the direction of the curves on the front of the body, let's take a look at the direction of the body from the side. First, the direction of the body from the side is almost like two lines. The first line comes from our spine. The entire spine. Let's analyze this line of the spine. From the side, it's composed of two S shapes. The first S shape curves forward from the cervical vertebrae downwards. Then curves backward at the thoracic vertebrae. And ends at the thoracic vertebrae. This is the first S shape, composed of the cervical and thoracic vertebrae. Now, the second S shape is the lumbar vertebrae. The lumbar vertebrae curve forward at this point, then curve backward at the sacrum, and end at the coccyx. The direction of the trunk is the combination of these two S shapes. Next, let's look at the lower limbs. Hide the arms. Due to the lower limbs of the thigh, the muscle group on the front side of the thigh protrudes forward, while the muscle group on the back side of the lower leg protrudes backward. In other words, from the side, we can see this kind of body curve. This body curve almost summarizes the entire form and direction of the lower limbs. Next, let's take a look at the upper limbs. The direction of the upper limbs is relatively more complex, but we can also identify some changes in elevation through certain high and low points to find some changes in the form. So the upper limbs. The upper limbs can be seen from the side as an S shape like this. The deltoid, along with the triceps, arches backward, while the biceps arch forward. From the side, you can see the highest point of the triceps, higher than the highest point of the biceps. This forms a difference in elevation, creating an S shape. Now, looking at it from the front, the deltoid muscle, the anterior deltoid, its highest point is higher. The horizontal position of the highest point is higher, while the highest point of the posterior deltoid is lower horizontally. So we can understand it as such a curve. Almost all. The curves all have a spatial twisting relationship. This upper limb turns from the back to the front. Then let's look at the forearm. It turns from the outside to the inside. It's all a winding relationship. The changes in these body curves mentioned above, and the twisting relationship of these curves in space, everyone must remember firmly and apply them in practical operations. Next, let me introduce some brushes that will appear in this tutorial and commonly used tool commands. Let's start with the brushes first. The first one is the standard brush. Standard brush. I often use this brush to paint vertex colors, instead of using its sculpting function. When using vertex colors, you need to turn off the add function, then turn on the RGB function, and this intensity adjusts the transparency of the brush. After filling the object with white vertex color, we can use this brush to paint vertex colors, pressing V switches between foreground and background colors. Of course, you can also press Alt to switch between foreground and background colors. The shortcut for the standard brush is BST. Next is the Move brush. The Move brush is a move tool. As the name suggests, it is used to move the surface of the object. In many cases, especially in sculpting, including adjusting the major silhouette lines, it is often used. I also want to mention here a similar brush to the Move brush, another move tool, the Move topological brush, called Move topological. The shortcut is BMT. When your object has quite a few subtools merged, when you need to adjust the shape of a specific object, you can use Move topological for that. You can see, when using this brush, it only affects the object you touch when you start the stroke. It won't affect other objects. The shortcut is BMT. The shortcut for the Move brush is BMT. Next is the clay brush, shortcut BCL. The clay brush is a brush that is very commonly used in the sculpting process. It has a very good shaping capability. It is very useful for adding volume to objects. In ZBrush, there are many brushes similar to the clay brush. Everyone can take them out and give them a try. Of course, you can also load an alpha to it in the early stages of sculpting, to give it more of a brush feel. Alright, after introducing the clip brush, is the flatten brush. The shortcut key is BFA. It's a user-friendly and handy brush. When you need a flat surface, or want to shape a form in a certain direction on the screen, using this brush is very comfortable. Similarly, there are many similar brushes like this flatten brush in ZB as well. You can also find and try them out. Next is pinch. Pinch brings the surface of the object closer to the direction of the brush. Often used to make the object sharp, which can be achieved very well with this brush. It is often used in conjunction with BDS. Damp standard. This brush, by default, it is set to C sub, so it's convenient for our use. Change it to C add, and slightly decrease its value. It can draw very sharp lines on the object's surface. Of course, we can also use the previous pinch. After drawing a line again, switch to the pinch brush to make this line more sharp and pointed. This brush is often used to define the highest point of the object or the lowest point of the object. Next, we will also use the inflate brush, BMA. Which means it will bulge the surface of the object where it is brushed. When you need to add volume to a certain area, you can first use the inflate brush to roughly create the volume. And then use flatten to shape it. It's also commonly used. Next, let's talk about the curve tube, BCW. Curve tube adds tubular shapes to objects. This brush. As you can see, when you drag a shape from the object, the tube is generated along the path of your brush. You can adjust the appearance of the tube by changing the brush size. But one thing to note is that the tube it drags out is unidirectional, meaning it is only perpendicular to the direction of your view. It won't have any rotational relationship. So when you need to use it, you need to operate it from the angle where it is most visible. Then, using the Move tool, Scale, Resize, and Rotate tools, give it more diverse spatial changes. After dragging out this shape, the software will automatically group it separately from other objects. Or you can directly press Ctrl-D to locally subdivide it and enter its editing mode. This brush is often used to create hairstyles. In the early stages of character creation, it can also be used to build some character skeletons. Similar to it, a brush similar to it is called BCJ. It's different from CulTube, as it drags out tube shapes, while it drags out sheet-like shapes. Another significant difference is that the shape it drags out overlays the surface of the object and changes along the surface of the object. Similarly, after dragging it out, you can press Ctrl-D to enter its editing mode. Okay, all brushes have been introduced. Next, let's introduce some commonly used tools. In the Geometry menu, Dynamics is something we often need. It's a command we need to use. Because when we're editing objects, we often need to pull out a more pointed shape. Or when adjusting the size. It will change the internal lines. So in this situation, even if we load more faces, in areas where the original faces are few, cannot add details. So in this case, we can use Dynamesh to restructure the surface of the object. To obtain a more evenly distributed surface for the object. This will make it easier for our next operation. When the object has groups, after you have activated this groups function, when using Dynamesh, it will subdivide the object through the groups. In other words, you will get two objects this way. The larger this value is, the greater the density of the surface it produces. Of course, when we are initially sculpting on a large scale, there's no need to set this value particularly high. Next is the ZBrush function. This command can restructure the surface of the object. The difference between this and the Dynamesh tool is that it performs a topologically significant surface restructuring. This value will determine how many faces there are after the surface is restructured. Let's run this command and see what the effect is. You can see that these two objects have been effectively redistributed in terms of their surfaces. And it is topologically significant. Of course, it also has some other parameter attributes. We will explain these in detail in the subsequent tutorials. Next, let's look at masking. Masking is a very basic command in ZBrush. By holding Control, you can add a mask to the object. In other words, a mask. The areas covered by the mask cannot be painted on. Pressing Control and clicking in the empty space outside can invert the selection. Here I want to mention the View Mask toggle in the Mask menu. This means that when I have a mask applied, for better visualization, I can turn it off. Then, the object will not display the mask. This way, I can more conveniently see the effect of my painting during the operation. Next is grouping. Polygroup. A commonly used command is autogroups. When two objects exist in a subtool, if you press autogroup, you can simultaneously separate these two objects into two distinct groups. You can also select a specific area and then press Group Visible to separate the selected area from the area that is visible into a group. You can also use Mask Group Mask to make the mask area you painted into a separate group. These are the three basic commands that are often used. Alright, we've basically covered all the basic commands. In order to help beginners immerse themselves more quickly in this tutorial, we will only use the most basic commands in ZB. To create this female character, we will start officially in a moment.